This is my first time at DefCamp, period, and first time in Romania. Taking the tour tomorrow, I'm going to be checking out castles. I know you guys are probably like, oh yeah, we can go to the castles anytime we want, but in the US, like, we're obsessed with castles, right? We're like, design your security by castles. You want something secure, you build your moat, you build your walls. We love that metaphor. But of course, you guys know, living out here, no one really uses castles, right? No one uses them anymore. And there's a reason for that. It takes a long time to build a castle, like 25, 30 years. It takes a lot of money to build a castle. And so as a metaphor for security, it kind of worries me. No one's using it, then how come we're using that as our metaphor? Especially when we know all the troubles with security. Now, you think about 25 years. About 25 years ago, this week in hacker history was the infamous smashing the stack for fun and profit, right? When we all knew, okay, software is the way people are going to break in. Software is the way we're going to break in. 20-odd years now we've been thinking about this. And 20-odd years now we've been pointing back to the castle saying, if only we had a little more metaphor around our defense in depth, if only we had a little bit tighter walls, a little more solid architecture. And of course it's not working. At the same time we're moving away from designing security as a castle, I hope. We're also moving away from designing IT and data centers. Moving to the cloud, moving to DevOps. And so there's this paradigm where we're trying to use a metaphor that takes forever to build. At the same time, we're trying to squeeze ever more speed and productivity out of our IT. So I've been trying to think about how we can do IT security differently. Trying to think about what other principles that we could have, what are the different ways we could use moving into DevOps in the cloud to think about this. The principles that I'm going to be talking to you about today look something like this, right? First, we need to stop building these castles. We need to survey the land first, fast, and often. And we need to leverage some standards and practices and defend from a position of strength. Use those, the survey, use the checklist, use our information to build a defensible position. And then build within our organizations this idea of street smarts, right? This idea of everyone pulling together to get things done. So today we're going to be looking at DevOps, today we're going to be looking at cloud, and today we're going to be bringing all this together and show how when we move to DevOps for speed or cloud for flexibility, we can, with security, match and move with IT and development. Make sense? And then we'll, of course, open it up for questions when we're done. So DevOps has been around for a while. My background was originally in financial services, and in this financial services firm, I was an early adopter of DevOps, specifically around rugged DevOps. If you guys haven't looked at this, this is the Rugged DevOps Manifesto. We've moved quite a ways from this time, but I still love this manifesto. I used to have it printed off on my wall, right? I'm rugged, and more importantly, my code is rugged. I recognize the importance that software has now, the foundation it's become in the modern world. This concept of rugged DevOps being building good, strong, reliable, consistent systems. From the beginning, security was at least considered as part of DevOps in terms of free from defect. Now, DevOps has jumped way far ahead. And today it's more about the pipeline, right? More about the structure that's used to produce code. Everything from building, to testing, to packaging, to doing release management, to doing configuration, and so on. So I want to walk through some of these steps next and show what they are, how they work, and where we might embed security. From the code perspective, it's everything we've been talking about forever. And if you caught April's talk this morning, this is fundamental SDLC. Right? Our developers are developing code in teams, in parallel, and submitting it up to version control, usually Git. Now, I like to say that if you write a single line of code, even if you write one line of code, you increase that attack surface. Right? You write two, and you get things like Slammer and NIMDA, right? These vulnerabilities that spread everywhere. That's because of defects, and we all know about defects, but there's a way of measuring defects, that's defect density. Defect density is the number of lines of code that are defective per 1,000 lines. So Coverty studied this. They looked at like 450 million lines of code, they looked at closed source, open source, and they found that on average it's 0.69. So every 1,000 lines of code that your developers are writing, you're going to have about one defect in there. And for every 20 defects, you're going to have something exploitable that allows the penetration testers, the red team, to find it, hopefully, or worse, the criminals to get in to break in. One line of defect, right? And it doesn't take much. You guys probably saw this with Jakarta, obviously the Equifax hack now, where they had this vulnerability in Jakarta multi-part parser. And the Jakarta was distributed as part of Struts, and Struts was used for writing software over a whole bunch of organizations, including Equifax, and that's what allowed the criminals to break in. Now, Apache and Struts is MVC, so model view controller, right? You write your code onto Struts, and therefore you don't have to write a lot of abstraction, you don't have to write the menus, you don't have to write the form handling, everything is handled within Struts. Very, very handy. Jakarta as a multi-part processor was what was used to upload files and upload extensions, manage the any sort of the uploads, right? One vulnerable in that was what enabled the breach. And if you peeled that back and actually looked at it, it was really, fundamentally, there's a cascade of effects, really fundamentally, just one line of code. It's the top line of code up there. As they were looking through each file, the developers thought, hey, sometimes someone gives me a file and it doesn't work. So if that happens, just keep trying. We'll try a couple different things to do it. So a good pen tester comes in and goes, or a good criminal comes in and goes, okay, we're going to throw something malicious. And it would hit that top line, it would get ignored and get passed through Jakarta all the way up to Struts, and then execute in Apache's context. And to anyone who was running Apache as root, of course, they're completely owned, but bottom line, they were able to install web shells. When they looked at Equifax, they found something like 30 different times this has been exploited in a web shell and uploaded, right? Very, very frequently, one line of code. So that defect density bites us quite frequently. What are some of the controls we can have around that? Well, one is design review and code review. Having someone who is familiar with security sit down with developers and say, hey, what have you done? What were you thinking? Design review is pretty important because oftentimes when they're in the design phase, that's when you can catch some items that, if they move forward, may cause big concerns. So we're going to look for, okay, I understand you're building this, but you realize criminals would do that with it. I understand you want to share all this data out, but you realize by sharing the data that way without having permissions on it, criminals could exploit the system. So the design review, having someone who's knowledgeable in security embedded in the development team. Code review is actually reading that code and looking for those errors. I'm sure someone was doing code review with Jakarta. I'm sure someone saw that line, but so oftentimes with code review, it can be kind of complex to actually catch those errors. So because of that, and also because people are expensive, we also have static analysis tools. Static analysis tools are going to read that code, they're going to run through checks, they're going to look for common patterns that may indicate the possibility of an error, right? SQL injection, cross-site scripting, the types of mistakes that developers make again and again and again will get caught with static analysis. Now, one part of that is to be successful, right? That street smarts is to embed developer securities within the developers. Bring those teams together. A couple different ways you can do that. You can actually have, I've seen development teams who has one or two people who are interested in security, and the security team empowers and enables that individual, gives them tools, gives them training, gives them a seat at the table with the security red team, and therefore the developer already has trust and relationship built up. Now he can bring those security skills into that development function, into that sprint, and make things happen. One way. Second way is a representative from the security team goes and sits with the developers. That also works. You want to be close. You want to build a relationship. Both ways work, but there can also be a scaling issue if you now have to embed a security architect in every one of your dev teams, right? That can get kind of costly. But fundamentally, what you're trying to do is bridge those two teams. Now, the next thing to think about with static analysis is that the time to run that security check must complete within the time of work. Now, what I mean by that is this. When I first put in DevOps in the financial services firm, we were talking like releases monthly. We thought we were smoking fast. Monthly releases, it was amazing. The velocity. Now, this summer I got called in by a CISO, and the CISO's like, yeah, they're doing this DevOps thing. Can you help us figure out how to secure it? So I go and I sit down, and we're meeting, and we're talking through the pipeline and what they're doing, and they're pushing code out 4 times a day, right? 4 times a day. So I said, well, what are you doing for static analysis? They're like, well, we kind of run it. You kind of run it? Yes. How often? Ad hoc. Okay, why is that? Well, it turned out the way they're running it took 72 hours to complete. So by the time they had pushed the initial change to production on Monday morning, they had to wait till Thursday to know if that build had been completed. So they completely cut it out, right? We have to get these checks within that time of build. We found a way to just scan parts of the code as they're submitting it, which was within that 4-hour block. Real tight then, right? Gotta move quick. Now, on the build side, once you've got that code, developers have written code, it's in version control. Usually you have an automation server here showing Jenkins, and what Jenkins does is it pulls all the build together and actually puts that code together, compiles it, pushes it out into an integrated test environment in an automated fashion, which is amazing. Now, the thing to know here is, with our developers and whatnot, is they don't just write all the code, right? We all use 1,000,001 libraries. Generally what we're seeing is a typical application may have 1,000 lines of code, but 1,000,000 lines of code in backend libraries. To be even more specific, it's around 100 lines of code in a backend third-party library to every 1 line of code a developer writes. On average is what I'm seeing in these DevOps teams. So if you've got an application, typical web application with a mobile and the API and everything, maybe 500,000 lines of code, you're probably looking around 5 or 50 million lines of code to support that. Now, I was talking about defect density earlier, 0.69. That works out to 345 defects in the code lines they've written, but around 34,000 defects in the code they're supporting these third-party libraries. Figure 1 in 20 of those defects is exploitable. You're looking around 2,000 defects, exploitable defects, in the libraries that these applications we're building are relying on. So we need good visibility into those libraries so that we know if they're vulnerable, so that we can react and patch them when they need. You know, think about, again, Equifax building on top of Jakarta and struts. They didn't have good visibility. They didn't even know that they had struts in that particular application that compromised. Someone did, but the security team didn't. And it only takes one exploit. The other thing that, the other example that we oftentimes use for this third-party thing is Heartbleed, right? Because everyone remembers Heartbleed, SSL broke, everything that was built on OpenSSL broke. There was heyday for a while as everyone could do information disclosure and dump passwords and everything out of websites. Again, thinking about defect density, 0.69 per 1,000, Heartbleed rolled out to just 1 line of code. They were silently discarding the excessive requests, and therefore it never got handled, it never got bubbled up, the exception was never thrown, and all the request was returned back, and that's how Heartbleed was able to take advantage. So Heartbleed happened, and everyone went, do we have Heartbleed? And the people without inventory did scans, went on there, oh yeah, we do. So they all went and patched Heartbleed. But, do you guys know how many vulnerabilities have happened in Heartbleed or in OpenSSL since Heartbleed? 96. 96 times something like this has happened where they've had to go back and patch and patch and patch. So organizations who don't necessarily have that visibility are in a real tough spot because every single time this happens, they're having to go rebuild their inventory, do scans, and so on and so forth. So when you've got libraries, such as what happened with Equifax, releasing all this data and credit cards, being reliant on struts, when you got libraries like that, we have to have a good control in place to know what they are so we can track patches and act accordingly. That ends up being software composition. The control for this is software composition analysis. And that software composition is part of surveying the land. What do we have? What are we trying to protect? And what does it mean to our applications? Surveying the land with a tool like software composition, such that when that bill goes in and it checks it, runs an inventory and produces that inventory ready on demand for the security team to look at. As well as then looking at the inventory against known vulnerabilities so that the security team can come back and patch. So, the next thing to look at, we had design review, we had code review, we had software analysis, and SAST. When SAST is running, as part of these build process, scanning the code, again in the time frame that's within the build process. You're building 4 times, you're doing it in about an hour, you're getting good intel. We want to create feedback loops, right? Where the security champion, either the developer in that team, or the security guy who's hanging out, and advising that team, can take those vulnerabilities and have good conversations with the developer. Each one of those conversations, line by line, scan by scan, is an opportunity for the security team to say, yeah, I know you're thinking that, but really you should think this. I know you're doing that, I see what you're going for, but really here's a better way. I know that this is an issue, but let's put in a fix so that you can code better. One of the applications that we're supporting from a red team perspective, every single time we come back out, we're doing these scans twice a year. Every time we come back out and we do a scan or vulnerability analysis or a pen test in the application, always had the same problem. There's always a way that the database was logging in that was exploitable that allowed the attacker to run this DBO. And they'd clean it, they'd fix it. Every time we give them a list and they'd fix it. And we come back and we do it again, and the same problem would pop up in a different app. We go back, they fix it, go back and do it again. Third or fourth time, we're like, why is this always happening? So we get all the developers in the room. We point to the code, we're like, why is this always happening? They're like, oh, that's the code off the wiki. What? Yeah, our internal wiki, we just copy and paste it every time we make a new code. And that's how we connect to databases. And then you guys come in and pen test and we change it. Can we update the wiki? Well, yeah, I don't see why not. So developers update the wiki, and from then on they copy the clean code, and we never found that again in another pen test. One time, done, fixed, right? These scan results, these findings are great opportunities to create that culture of street smarts, giving them the right tools so they can do the job quickly and efficiently without having to wait for us to do the scan and come back and tell them they did something wrong. And it's also about creating that culture of quality, right? One line of code at a time. So let's talk a little bit about tests. That was build, now we'll talk a little bit about tests. When you get to the point where we've got the code's been pushed to Git, and Jenkins has done its magic, now it's an integration, and now they're going to move from that to the acceptance, and that to the manual test area. Each one of those steps is automated with a series of tools. Some as simple as curl, some as simple as bash scripts or SSH, some a little bit more extensive. You can look at things like JUnit for unit testing. You can look at things like Karma for testing UI. When it moves to QA, you can run Groovy scripts or Cucumber, Capybara. You don't need to know all these, but what you do need to know is within a DevOps environment, for the very first time, we're able to, as a security team, say, here's the list of things I want you to check, right? If you caught April's talk this morning, she's talking about the checklist. Some of those checklist items, some of those abuse cases, the misuse cases, you can create a curl statement for, right? I should never be able to log in and do this as an administrator or as a regular user. You can create a UI script. When I click this, this, and this, I should not be able to move forward or backward. You can look at things like enumeration. All right, change the ID, see what additional data. I should never be able to do that within my token. All these things we can now create within a Cucumber script or Capybara script or a simple curl and give it to the DevOps team. They're going to run it every single time, 4 times a day when they push code to production. It's bloody brilliant, and it makes our job so much easier. So I love the automation that DevOps provides specifically around the testing. In addition to that, we can go back to the security controls that we've known and loved forever, such as dynamic testing, right? If static analysis writes the code and looks for vulnerabilities, dynamic analysis is going to click through that application and specific users and look for things like cross-site scripting, SQL injection, what have you. So dynamically look for vulnerabilities in the code. And interactive testing is going to combine those two. Interactive testing is also oftentimes used with someone who's manually testing. So if you think about that manual test phase in DevOps, it's oftentimes wrapped around IAST and looking for vulnerabilities that may crop up as the user is using that application. We can embed these within the app. And what's nice about that is because it's constantly scanning and crawling, it doesn't have to necessarily restart or break the build process. Jenkins can still push out, your scripts can still run, and this can run continuously in the backend without slowing down or impeding the developers. Now it's going to, throw up alerts, and we're going to have to go, well, okay, what do we need to do about that? But we can run these seamlessly behind the scenes. Now, the concept of this is back to being rugged, right? I'm rugged, and my code's rugged. When I built DevOps teams internally, we relied on that very heavily. Developers want to know that they're doing a good job, right? High degree of craftsmanship, high amount of pride in what they build. By tying that pride in what they build to security defects and making defect density and security part of quality, we can get a lot more buy-in and a lot more, yeah, I want to do the right thing, I want to copy the right code, I want to put the right stuff in place, right? And leverage that excitement in DevOps to drive the security program forward. And that gets back to street smarts. Unifying code quality and security around one theme in the minds of developers. Now, in DevOps, as you pass from system to system, from state to state to state, there's this concept of gate, right? We can gate at any point in time because it didn't pass a UAT script, because you've introduced a feature that wasn't expected, because whatever happened has now broke the build. You can gate at any time. Developers usually decide when they want to gate, and in conjunction with security, in highly rigorous application development environments, security is also a gate. Yes, I passed it, you've passed all my checks, or no, wait a minute, you need to do this other thing. Some teams I'm seeing will do the gate automated using SAS, DAST, and ISST. Some will do it manually because maybe they're pushing to production once every couple days, so the security team can inject and look at it. And some of them are saying, hey, look, we've now given the developers enough information, enough tools, enough resources. We're going to let the developers choose whether or not they want to gate. And we as a red team will have visibility into that and have conversations about why they chose to gate or not. We're going to empower the developers to make that choice. I think it's almost a maturity level, right? As your developers get more comfortable, more understanding of the security concepts, they can make better choices themselves, and they can own those choices, and the gate can move forward or not. All right, so now we get to deploy. So, same thing, we got a developer, a whole bunch of developers. They've written code, Jenkins has pulled it down, pushed it to the integration test environment, and we've done static analysis and done everything we could there. Now it's moved to the acceptance, we've done some additional tests there, right? Dynamic, IAST, and what have you. Hopefully also leveraging things like Cucumber and Capybara. It's moved to the manual test, someone said thumbs up, yes, push to production, and now Jenkins is going to deploy that build into the production environment. Where bad things happen because it's on the internet, right? When we go to push it to production, one of the main things about that whole pipeline is to protect the pipeline itself, right? The integrity of that CI/CD, if it's fully automated, now becomes paramount, because a good criminal is going to look at it and go, code starts there, and it goes there, and now it's production. If I insert my stuff here, developers don't know, I've already passed the test. Clean code, as long as my backdoor's clean code and passes the static analysis, now it's in the build. And we start to see this more and more often. The two primary cases being MEDoc, which had disk coder enabled or bundled with it, and of course C Cleaner, which had a Trojan that was injected in the code stream. So it's absolute paramount to protect that CI/CD itself by looking at things like change control and integrity monitoring and wrapping everything around it. Now the other thing is, once it's in production, we want to make sure that we're monitoring that very well, using things again like interactive scanning, scanning for vulnerability management, thinking about how much of these vulnerabilities are third party and whatnot, running RASP and running web application firewalls, so that if anyone does break into it, we're monitoring, we catch them, and we actually apply those hotfixes. I've seen many organizations who actually use RASP as a defense and a detective tool. Because now we've exposed everything to the internet, when the bad guys attack it, that's how I know where my vulnerabilities are that were probably missed further on, because maybe we flexed a gate or missed a rule. Kind of interesting, we're basically using the criminals to do the pen test for us, right? Free pen testing, everyone gets one. But we know vulnerabilities are inevitable, on struts. One of the reasons why struts was so hard is because of the MVC. Actually patching that broke a lot of other applications. So many organizations had to wait months before they could patch it. Well, their dev team figured out what needed to change, upgraded the code, upgraded the libraries, did all that sort of thing. So we know that we're not always going to be a patch right away, which means we absolutely positively need those WAFs, so that we've got tools in place that can deploy a patch and buy us some time, right? And WAFs can be bypassed, we all know this. I was doing a CTF with some of the local guys back in Michigan, United States. Now, are you CTF? You guys play that? Anyone here play that? Oh, you guys want to play it? Yeah? It's amazing, isn't it? They give you 1,000,001 applications. They're all vulnerable. You have no documentation. You go live, and it's like 3 in the morning our time. And you got like an hour to get a VPN up, and everyone's staring at you, and nothing works. And you boot everything up, and everything's vulnerable, and then the VPN's open, and everyone attacks you. It's great. It's just like the real world. So when we did that, we did our, a few years ago, we did a WAF. But we felt real good because no one was able to get our flags. Like, yeah, we're doing good. And hour 1, hour 2, don't get our flags. Hour 3, we're trying to figure out what the vulnerabilities are, and we're replaying the attacks that people are using on our WAF and using them to attack other people. About hour 3.5, one of our team members started bragging about our WAF, which you should never ever brag about your defense. He's like, we got a WAF, you guys can't get us. It took him about 20 minutes to figure out how our WAF works, bypass it, and then we went from like 10th to 150th. I mean, we were just floored. It was game over. So we know WAFs can be bypassed. But at least with WAFs, we have ability to have a way to monitor, right, without that patch, a way to buy our guys some time, right? As Jake Williams on Twitter says, grant me the serenity to monitor the things I can't patch. And without that ability to do that monitoring and do that reaction, we're just at the whims of the internet. So we want to constantly monitor the user behavior and note the way the applications are used and abused, again, as part of surveying the land. How are people actually using our stuff? And we know, of course, criminals are scanning the internet all the time. One of the ways that we used to talk about this back in the day was the SANS Institute did the study where they plugged a poor Windows XP box up to the internet, and within 20 minutes it was compromised. Right? Bam, like that. And 20 minutes seemed like a long time at the time. SANS is now redid this in the day and age of Mari. They did a DVR and they found it was compromised every 2 minutes consistently, the minute they hooked it up. This is what I like to call the Age of Ultron rule. If you guys have seen the Age of Ultron, great robot, great technology, a lot of time went into it. They hooked it up to the internet and everything went to hell. Right? We need to be ready for when those guys come at us. So constantly scanning for vulnerabilities, constantly looking for the weaknesses so that we can identify them before the criminals do and we can patch them, part of surveying the land. Now, that's all the controls, and at the end of all that, then we bring the pen testers, hopefully. Then we bring in the pen testers, and that's a whole lot of stuff to do. A whole lot of stuff to do. Now, hopefully we can automate a lot of this. So the current survey is sort of about 39% of DevOps have automated the security controls, and more mature orgs is getting about 60%. So we're already on our way of doing that. But we also don't want to just throw a bunch of security requirements at the DevOps team. When we talk about securing without slowing, we have to take into account these DevOps teams, how much change they can actually absorb. One of the nice things about DevOps in a Scrum, if you've got a week-long Scrum and pushing code every 4 days, you get a pretty good handle of what amount of work the development team can absorb. And so by having good conversations with developers and looking at that amount of work, we can then tune how much of these security controls we can put in place and when, right? We're going to add a control and we're going to see a slight blip in production. We're going to add another control after we have our major release because we know at the end of the quarter when everything goes live, there's going to be some slack time with the development team. We can start phasing in controls in such a way that leverages DevOps speed and agility, leverages DevOps ability to do estimation by looking at how many controls and how many different new tasks we can ask them to do at any given time. And knowing that once we put it in place, there'll be a little bit of additional work, but then it's going to get faster, they're going to get better, they're going to get more acclimated to it, we can automate it, we can talk about culture, and that work gets absorbed in the dev stream. It's a really fascinating way of rolling out controls. All right, so that's DevOps. We're going to talk a little bit about cloud. Obviously, most of you guys know all about cloud. But what's interesting is because so many of my customers, especially CISOs, came out of the IT realm where you're responsible for what was in your four walls, very oftentimes they're very good at talking about the cloud that's within their castle, but they're not very good at talking about what actual cloud is, right? What platform services, infrastructure services, what are the security requirements of that? And because so many of the apps in the cloud have originated from the marketing team and some end users, a lot of times the CISOs don't even know that they're in the cloud. My prime example of this used to be around 2012, a guy was bragging, he was the chief information officer, he was the chief learning officer. He was bragging about how great the organization was. They learn a lot, they spend a lot of time learning, they're really focused. And this metric of that was how much money was being spent in Amazon. Because in his mind, money spent in Amazon meant books and learning. The CIO heard that and said, wait a minute, we're spending several $1,000s a month on Amazon in books? And that's how the CIO learned that they're in the cloud. Because someone just mentioned, hey, do you know how much we're spending on Amazon? We learned a lot. And like, nah, that's not learning. That's a whole lot of VMs. So there's several ways to slice and dice this. I personally prefer the model of on-prem being, the happy pig, infrastructure as a service being the bacon you buy, platform as a service being the bacon you consume, and SaaS meaning all you have to do is enjoy it. With respect to cloud, each one of these areas brings its own security concerns, right? Each one of these areas brings its own security controls too. And because IT folks, specifically internal security officers and IT officers, have focused so heavily on prem, they oftentimes don't quite have a good grasp even on what the difference is between platform as a service and software as a service is, let alone what security controls are available to them. So when we're talking about moving fast and enabling the organization to move fast, we have to start with classic IT and then scale it up. With classic IT, we know that like 90% of companies get attacked with 3-year-old vulnerabilities. There's 1,000,001 O days out there, right? I think there's like 245 that were discovered this year. But almost all the time, it's some old vulnerability that someone's scanning and found a way in. So of course we need to do vulnerability scanning. It ties back to that DVR that was being beat up every 2 minutes. But also too, that's DVR, one of the main reasons it's getting beat up is because they're trying default creds. So it's imperative that we not only scan internal on-prem and cloud on-prem or cloud tech for vulnerabilities, but also for configuration mistakes. You don't have to pick on Equifax, but they were found to have sites out there with admin, right? We hear about this all the time. Or as we heard this morning with Inbar, admin and no password, which is even worse. We need to be scanning for those types of things, both on-prem and as we move into the cloud. Especially as we move into the cloud, because if it's on-prem, chances are the IT guys have never noticed because a firewall protects us and it's not been an issue. And now we're exposing that to the wider area. So that's good old infrastructure vulnerability management. Again, another way to have feedback loops, right? Creating that culture of quality, one change at a time, one missing patch at a time, one misconfiguration. Organizations with really good vulnerability management have had a tremendous amount of success with their IT teams because like, hey, this missing patch, you know what it means? Like, I don't know what that means. Let me tell you what it means. Because of this, we could do remote exploitable code. What do you have that could be on the network and be remote exploitable? I don't think anything. Yeah, you say that, but do you realize that when we did an external scan, all these things are out there? And then they open up the eyes and we can have some good conversations about what to do next. Now, in terms of moving the infrastructure to the cloud, we need to start rethinking all the infrastructure and how we put things together. And again, I think oftentimes we internal folks get kind of stuck in our ways. This is a factory. Down here you can kind of see where the concrete is broken. Original factories were all steam powered. So because they're all steam powered, you'd have a really big steam engine right here and you'd have the belts run through all sorts of things, right? There's lots of museums will show this. We got one belt that powers all the machines all the way through. It was really horrendous for any type of assembly line or folks who were trying to get velocity out of their manufacturing line, but really, really convenient because you only had one motor. Now, the minute we went from steam to electricity, you think someone would go, this is great. We had this problem with manufacturing, but now we can put a motor in your station. We can move things around. We can be agile. And we can, move stuff in a couple days and adopt new products. You'd think that we think like that, but instead what we did, at least throughout Michigan where I'm from in Detroit, is we cut the concrete, we moved the steam, and put in one giant electric motor, and continue on doing business the exact same way, right? It's like, why? There's so much potential here. Yeah, but I know that I'm really comfortable with my belts. So we get the same thing with IT because they're like, there's so much possibility if you use software as a service, you don't have to write your own apps. Or platform as a service, so we can just consume the database, you don't have to have a database administrator. They're like, yeah, I know, but I really like owning that instance, so just give me VMs. You're like, all right, spend your money that way, but you're not getting a lot of the benefits. And it also limits the amount of visibility that any one organization has. Recent surveys show that CIOs think on average they're using around 30 to 40 cloud apps. But when you actually look at the perimeter, the organization is using, 928. A little bit of difference there. And when you think about vulnerabilities and think about surveying the land, huge amount of gap. So one of the ways I found this out is we do business continuity assessments. I sit down with the business, I'm like, what do you use? And they're like, Salesforce, this, that. Like, yeah, but what about technology? Yeah, Salesforce, email. Like, what about internal technology? You mean like Dropbox? And whenever we're on the CIO, I was like, I didn't know we were using all this stuff. He's taking on his notes. Like, yeah, let me tell you about the guy who didn't think he was on the cloud until he saw his Amazon bill. So we need to know what we have, and we need to know what it means in terms of clouds as we're helping organizations build the infrastructure that DevOps will run on, serving the land. And also, as we learn that, that allows us to have one conversation at a time with the business about what they're using, why it matters, have they thought about security, have they ran it by procurement, all those sort of things. Because a lot of the decisions that are going to be made about the apps that we use and the security posture of them is no longer made by a central function, right? It's whoever had the credit card and had the business need. So this allows us to drive that security culture in that conversation. Then we need to make sure that they've actually configured it right. I love Gartner, not that they're pointing fingers, but yeah, 95% of all the cloud security failures will be your fault. Not my fault. Yeah, it's the customer's fault. Because we put this stuff in the cloud and we shoot ourselves in the foot. And we've seen this a lot just with S3, just S3 alone. I could probably do like a blog or video every day about an S3 breach. Verizon's up there. It wasn't actually Verizon who got breached. They had a third party who put all the data, customer data in S3, didn't secure it. Viacom got hit with, what was that? I think, oh, they were my favorite. Viacom was doing full system backups to S3, including password hashes. And then Accenture decided, hey, we love encryption. We're going to encrypt everything. That's fantastic. And we're going to store our encryption keys in the cloud so we don't lose them. And an unencrypted, wide open S3 bucket. So these types of things we can identify and we can correct. And what's nice about it is we can identify and correct it. Those permissions are not going to slow down the business, right? They're not going to slow down the DevOps team. We can still maintain that velocity. So when it comes to on-premise and IaaS, we're looking at things like the CSE, right? The CIS critical security controls. We're looking at the CSA clouds matrix. We're using these things as checklists, starting points, ways to have conversations with the business about what's going on and what they should do. This becomes our backlog of all the things we could do, not necessarily the things we will do, because of course, you can only ask so much. The other thing that I think is absolutely fascinating when we talk about infrastructure as a service, platform as a service. Remember I said DevOps, every couple of hours they're building a new environment and moving it, right? Building a new environment, testing and moving it. Some of the DevOps customers that I work with even take this to patching. Every time a new patch comes out, they apply it to their production environment. They brand new, don't apply it. They build a brand new production environment, automated. They patch and they apply the code, make sure it works. And if it doesn't work, then they roll it off. In a couple minutes, someone may have complained that the web app was down. Right? We all had to refresh. We figured out a conference Wi-Fi. Very, very quick and very agile, which means that we can look at things like reference architectures and vendor recommendation security controls, and use those reference architectures from Azure and Amazon, all these recommendations about how to build this thing right, and give it to the DevOps guys, and they can go, sure, I'll try that. Try it, works, great. If it doesn't, no harm, no foul. We figure out what the gap assessment is and figure out what to do. Because of that speed in DevOps, we can adjust and take these things on even faster. So that's, if it's ours, you'll see above. 99 problems, sorry. But 99 problems, but vendor risk management ain't one. Okay, so vendor risk management is the other way that we can do it if we're absorbing other people's apps. Putting out the surveys, demanding that they uphold a certain level of requirements, and checking them, auditing them against that. Vendor risk management is so incredibly powerful because a lot of the work I get involved is the company comes to me and goes, yeah, I'm concerned about security and I don't want to be breached. Like, yeah, everyone says that. I'm like, yeah. So we don't want to be breached, but what's really important is if I don't meet these security requirements, my customer's not going to buy from me. So can you help me meet these security requirements? And of course we don't want to be breached. Like, sure, absolutely. When it comes down to hard and fast cash in a capitalist society, security gets done. And we're seeing a lot of security in our customers get done because they want to meet that vendor risk management. So to large customers that say, hey, ask for those, put the surveys out. Even if we think that maybe they're just checking the box and not being honest, put it out because it's going to drive behavior. All right, so standards and practices, using control frameworks to get quick insight into the industry standards, generate our checklist and figure out what we can do next is reference architectures and so on and so forth. And then use those controls, start with ones that provide visibility. Back in the day, everyone's like, oh, never run as admin, right? We've all given this control recommendation to everyone and their brother. Never run as admin. I remember being somewhere and I'm like, what should we do for security? I'm like, change all your passwords and never run as admin. They're like, great. Can you give me any proof that that would actually matter? Like, sure, let's do that. So we put in place a control and we tracked over a 3-month period how oftentimes running as admin actually caused a problem. And in many parts of the business, it didn't cause a problem at all. There's like 2 business units that did. We're like, we're gonna fix those. And then we went and we're like, hey, let's have a conversation because you're causing issues. And it was a much better conversation to have, right? Because we had that visibility and we had insight. So always start with visibility. The other nice thing about visibility, in addition to having a good business case and being able to push controls through, the other nice thing about visibility is it doesn't slow us down. As we talk about securing without slowing, adding visibility, adding that visibility control doesn't slow down developers, doesn't slow down engineers. It allows us just to see where the problems are and then figure out what we need to ask them to do. Survey the land and then have those conversations. All right? And when we have those conversations, we do a gap assess. Everyone's got their own maturity model. There's 1 to 5, there's 5 to 10, there's CMMI. And I see so oftentimes we have these maturity models, we have the conversation, and people are like, no, I'm a 3. I'm like, no, I'm a strong 4. And it bogs down. I argue to keep it simple. One of the ways I love to keep it simple is 0, 0.5, or 1, right? Get cape, wear cape, fly. When we talk about security controls and do that assessment, just keep it really, really simple. A lot of that is interview-based, and I love security interviews because when you do a security interview, you gotta think about castles. Everything seems pretty and nice. And then when you actually look at it, it's usually not, right? It's a little bit of a difference. So after we have that interview about the control, and after we have, a rank of 0, 0.51, and we talk about how we can make them go faster, it's absolutely paramount we actually do some technical validation. When we talk about building a defensive environment, and talk about our general IT controls. I like to validate those in several ways. One, does it exist? Do we say we have a door? Is the door even there? Believe it or not, oftentimes in my organization, when I'm helping a customer, it's not, but the developers told me, yeah, they lied. Or is it effective? The door is there, but it doesn't work. We've got disk encryption. That's fantastic. Walk through the developers. What's that code on your desktop? Oh, I don't know, the IT guys put something on. Sometimes it doesn't boot up, so we all have the code on our desktop so we can get in real quick. BitLocker key, great, on all the desktops. Is it circumventable? Okay, we have it in place, it's running, but can the bad guys get around it? Or is it actually something that stops us, right? We got the door, it's locked, but the window's open, circumventable. And the last one is it operational? As we're doing these tests, as we're doing these things, does someone have visibility into it, and do we have a response? If someone's banging on the door, does the alarm go off so that the cops arrive, right? 4 ways of testing these controls. So when we stand up and then test to our things, we don't sound like Equifax. Man, keep kicking on Equifax. Did anyone think when Equifax happened, thank goodness I never have to hear about Target again? It's like, now we have something else to talk about in security. But Equifax had this comment like, oh, well, we have FireEye, and FireEye protects us and keeps us safe. There's a FireEye webinar or a white paper that they almost immediately pulled down after the Equifax hack. But we can never really say we're secure, right? You can't attest that. We know this as security professionals. It's a very, very dangerous thing to do. What we can say is by using visibility, using that checklist, we can attest to a strong set of detective and prevention controls, right? That were there the last time we checked. And then by looking at DevOps and figuring out how quickly we can check, we can do that iteration over and over and over again. And that's that position of strength. As opposed to a castle, we have a net of controls that we move to whatever we're trying to control whenever we are. And the minute that threat is no longer there, the minute our detection goes off, we move that net somewhere else. We move those defenses where they need to be in a very nimble way, using automation. And of course, again, knowing that the organization has a finite capacity. Just like DevOps has a finite capacity, IT also has a finite capacity, our user population has a finite capacity. It's a little bit easier in the DevOps world to see that, because on a weekly basis, they're saying, here's our capacity, which is really nice. But we can still get a good handle for that from the business. So for example, you're asking HR to make a change. when's a good time? Well, probably after insurance benefits in the US. If you're asking billing, when's a good time? Second week of the month after all the bills and invoices have went out. I'll have a week then, right? Knowing what that window is and what that capacity is so we can ask them to make changes in the right time. And phasing in those controls in a way that makes sense and doesn't exceed the business's change rate. So that's securing without slowing. You know, to me, it all goes back to those castles. Harlech Castle in Wales is like considered like the quintessential model of castles, and I think really illustrates how broken that is as a model. As a percentage of revenue, it took 10% of the kingdom's revenue for several decades to build Harlech Castle. If you guys go by Gartner's stats, and many of my customers would tell you this is overly optimistic, percentage of revenue is 0.2% on IT security spend, right? Tiny, tiny, tiny amount of money actually goes in IT security. And we're asked to stand up, we're asked to defend, we're asked to deal with DevOps, we're asked to deal with the velocity, we're asked to deal with all these things. Then when it goes wrong, some CEO's like, yeah, it was that guy, he didn't tell me what to do, right? Or he didn't put the patch on. It's a very, very tricky spot to be in. So castles don't work. And security teams used to be the team that said no, right? We're the team that stops risk. And we got past that. A lot of people now are like, I'm a CISO and my role is to not be the department enough. But instead they're like, well, we just asked them to slow down and think. But whenever you ask the business to slow down and think, they're gonna work around you, right? And we see that more often than not. That's one of the reasons why usually when I get called in to look at DevOps, the DevOps program's already been running, usually for several months, sometimes a couple years, before the CISO's got wind of it and wants me to secure it. We need something very flexible, and it can't be these rigid architectures. To use a quote from Bruce Schneier, you know, the problem in architecture is it tends towards permanence, while security threats change much faster. Again, we need that net, that nimble net of knowing what we're dealing with. And castles are manual, they're not automated. We can learn so much from DevOps. There's a high degree of craftsmanship needed in every single level. And we know we don't have enough people in infosec, so we need something that's standard that you can get to speed very quickly. And it's a 25-year project, right? Whereas oftentimes in security, we're talking about 3 to 5 year roadmaps, and DevOps is talking next week. We need to really tighten those circles. If we start to think about security as a product in this world of securing without slowing, it looks something like this. We're trying to protect the business, what makes revenue, what keeps the lights on, availability, integrity, meeting customer demand. We're trying to prevent the crime, right? What are the criminals motivated to do? In each one of those areas, again, looking at Bruce Schneier, there's a feeling of security and the reality of security. There's the photo that they take and there's the background reality of how it is done. We need to get to both. And one of the ways to do that is to kind of reconsider security as a product. And when you reconsider security as a product, it opens up several insights, right? So for example, features in product development now become our security requirements, driven way back to those checklists we talked about, but also things we've observed, best practices and what have you. The process of rolling out security. Wouldn't it be great if we could learn a little bit from DevOps? Wouldn't it be great if we could do weekly sprints or monthly sprints and roll these changes out at the pace of business? Kind of a different way of thinking about it. It's no longer a 3 to 5 year roadmap. It's what can I reasonably accomplish from my backlog of features right now. And finally, in terms of securing without slowing, looking at user experience design, industrial design, these principles that make products easier to use, make the world a little bit better, make the things that we use every day easier and simpler on us. Could we use those and recognize some of those design principles in our security discussions so that we make security easier and simpler for the end user? I think we could. I think it's a little bit different way of doing it than relying on castles. So I'm going to sum up the principles and we'll wrap it up. I know we're at the end of the day. Stop building castles. Create things that are flexible and fast. Survey the land often. Have good visibility into what we're trying to defend, what people are building, what we're trying to protect, and what the criminals are doing with what we're building, what we're trying to prevent. And focus on that visibility and that knowledge to build intuitions in ourselves and in our peers in IT and development in the business. Leverage standards and practices, right? Checklists are amazing things. I know in security we like to scoff, I don't need to be checkbox security. Yeah, I get that. But they're a great list of things that we can do and we should consider. Don't do them all. We'll put them on the backlog and figure out what we can do. But they're a great list. Come from a position of strength, right? Create and assert a defensive core. Can never say we're secure, but we can say for these things, these 5, 10, 20 security controls, that made sure it exists, that made sure it's effective, that it can't be circumvented, and that, by God, if someone does try and circumvent it, I'm aware of it, I get visibility into it. That defensive core that we can throw a net around things as we build new functionality and remove that and save money from a security perspective when it no longer matters. And of course, to do this, we got to have good buy-in, good support from our business community, from our developer community, from our IT community, and that goes back to creating those street smarts. Having those conversations on every vulnerability scan, every new patch, every line of code, every new cloud application that they, add to the 928 that is out there, we only do 40 or 50, right? Using those changes as an opportunity to have conversations about what it means to the business, what we're trying to protect, and what we're trying to prevent. I think these are good principles. It's a starting point. It's a real rough starting point, but I think it highlights some of the ways that within the DevOps environment, as the world continues to go faster, we can indeed secure without slowing.